This is a review of Chapter 5. Number 1 says, if we know the measure of angle 2 is 110 degrees, that's here. Okay, that's 110 degrees. Find this measure right here. Well, to me, they both look obtuse. So if they're both obtuse, then they're the same. They are congruent. So the measure of angle 8 is 110 degrees since it's the same. And now we need to justify. That means use a vocabulary word to show the relationship between 2 and 8. They both look like they're outside these parallel lines. And they're on alternating sides of our transversal. One is to the right and one is to the left. So that is called alternate exterior. When they're on the outside of the parallel lines and on alternating sides of the transversal. All right, for number 2, I'm going to erase what I have here so that I can do this. It's the same picture, but now we have different measures. Okay, now we're talking about angle 5 being 70 degrees. So here's angle 5, it's 70, this little teeny angle here, going from there to there. So if that one is 70, we want to find angle 7. Does angle 7 also look small or acute? To me, yes, it does. That means they're the same. They're either the same or they add to 180. Those are the only relationships between any two angles in this picture. The same or add to 180. So in this case, they're the same. So we know angle 7 is also 70. And we need to justify, which means use a vocabulary word. Those two angles are opposite each other when these two lines cross. They're opposite from each other there. That's called vertical angles. Those are vertical angles. All right, number 3. We have a right triangle, which has an acute angle that measures 42 degrees. What are the measures of the other two? Draw a picture. I always draw a picture if they don't give me one. All right. It says it's a right triangle, which I know has a right angle in it, which of course measures 90 degrees. I know one of the angles is 42. It doesn't matter which one you call 42 degrees. I'm going to call that top one 42. So we can find the third one in there, because if we add up 42 and 90, we're going to take that away from 180. So all the angles, this one, 42, plus the 90-degree angle, plus this missing angle x, has to add to 180 degrees. Because it's a triangle, they add to 180. So to solve for this missing angle x, you're going to combine like terms. 42 and 90 is 132. And then we're going to subtract that 132 to get x by itself. And whatever we do to one side, of course, we do to the other side. Okay, that gets rid of our 132 on the left. So x is 180 minus 32, which is, this is a 10, so this is 8, and this is 4. So the missing angle is 48, and of course they asked for the other two angles. So if they gave us 42, the other two angles would be 48, the one I just found, and of course the one we already knew about, which was 90. So that was the answer to that one. All right, number 4, we didn't really talk about this other than one day, but some of you might remember the formula that's already written on your paper this year. Here we have the sum equals 180 times n minus 2. You should already have that on your paper. And n is just standing for the number of sides. I'm going to write that up here. N equals number of sides or number of angles, because they're going to be the same. So how many sides does it have? I got 1, 2, 3, 4, 5, 6. So it has 6 sides. So all you got to do is plug in 6. The sum is going to be 180 times 6 for n. And of course, if we're simplifying this, we have to do parentheses first. So we do our 6 minus 2, which is 4. and then we multiply 4 times 180. So the sum of all these interior angles is 720 degrees. Okay, number 5, write an equation you could use to find the length of the missing side of the triangle. Then find the missing length and round to the nearest tenth if necessary. So we know if it's a right triangle, we know that a squared, if this is a and this is b, a squared plus b squared equals c squared. So I'm going to write that formula down to show that I know what I'm doing, which is what you're going to be doing too. Okay, a squared plus b squared equals c squared, so just plug it in. We have 3.1 squared plus 6.4 squared should equal c squared. So if we want to find c, first we need to multiply here. 3.1 squared is going to be 9.61. That's just 3.1 times 3.1. Plus 6.4 squared, which is 40.96, will equal c squared. Okay, and when I add these two together, I am going to get, let's see, 50.57. And then if I want c by itself, I'm going to have to take the square root of both sides. So I need to square root this one, and I need to square root c squared. That will give me just a c. And the square root of 50.57, when I round to the nearest tenths place, is 7.1. Okay. Number 6, we went too far. 6 is right here. Use the distance formula to find the distance between the pair of points. Round to the nearest tenth if necessary. You can do this on graph paper if you want. You would plot the points, make a right triangle, and find your hypotenuse. I'm going to use the distance formula though. The distance formula, we always write down our formulas first so that we remember them. We have x2 minus x1 squared, so that's the differences in the x's, plus the differences in the y's squared, and of course we take the square root of it. This is just the Pythagorean theorem done algebraically. So if we label our points here, we have x1 and y1, because that's our first x and our first y. And then, of course, x2 and y2, there's our second x and y. And now it's just about plugging in our points. x2 is negative 7, and then I'm subtracting x1, which is 2. And y2 is 9 minus y1, which is 11. All right, so we have the distance equals, let's see, negative 7 minus 2 gives me negative 9, and I'm going to square that. And 9 minus 11 is negative 2. I'm going to square that as well. Don't forget, when we square something, that means we multiply it by itself. Well, any number times itself will always end up being positive. If you're multiplying two of the same number, it's either going to be two negatives or no negatives. That gives us positive. So negative 9 times negative 9 is positive 81. Negative 2 times negative 2 is positive 4. All right, and this becomes 81 plus 4 is 85. Then we take the square root in the end. This is rounded to 9.2. Number 7. I'm not so worried about this one, but let's just do it really quickly. What is the measure of an exterior angle of a regular nonagon? Well, a nonagon has 9 sides. Write that down. A nonagon has 9 sides, and we know our exterior angle formula. Exterior angle formula is just 360 degrees. Oops. 360 degrees divided by the number of sides. n. And when it's a regular polygon, that's how we find these. It only works for regular polygons, which means all the sides and angles are congruent or the same. Okay, that's what regular means. All sides and angles are the same. So an exterior angle for this will be 360 divided by n, which happens to be 9 for this one. And 360 divided by 9 is 40. So each exterior angle in this regular nonagon will be 40 degrees. And of course, just to show you a picture real quick, an exterior angle is when it comes out here. It's this angle here. That's all they're talking about. Of course, that's not a nonagon, that's a triangle, but I'm showing you what it looks like. So we didn't talk about that too much. But we did do stuff like problem number 8, where we have to solve when we have two interior angles, right? These are inside the triangle, and we have one exterior angle. All right, you know the sum of the interior, all three in here, that this one and whatever this is, add to 180. But we also know, which most people figured out on their own, otherwise maybe you figured it out from Alex, that the exterior angle is just equal to the sum of the two remote interior angles. So let's say that again. So the exterior angle, please write this down. The exterior angle equals the sum of the two remote interior angles. Okay, and remote just means the far away ones. This one and this one are the farthest away from that exterior angle. I have 100. So I'm going to plug stuff into this equation that I have here. What is my exterior angle? It's right here. It's 100 degrees. So that 100 degree angle equals the sum. Sum means to do what? It means to add. I'm going to add my two interior angles. 2x plus 3x. That's all it says. The outside one equals the sum of the two inside. So to solve for x, I have an equation. I can combine my like terms here. This is 5x equals 100, and of course divide by 5 to get x by itself. That's it. On the back, numbers 9 through 13, actually 9 through 14 have to do with this picture we have here with the two parallel lines being cut by a transversal. So they're asking what angle is alternate interior to angle 7. So we find angle 7 and show it like this, and find the one that's alternate interior, means inside, alternating side of the transversal. So here it is, inside and on alternating sides of this here transversal. And of course, inside means inside the parallel lines, right? Those are both inside the parallel lines, but on opposite sides of the transversal. So that would be angle 5. Which angle is corresponding to angle 9? Okay, which angle is corresponding? It's the one that's in the same position in relation to the transversal. So look at the other line. If you look at this line here, this 9 is down here, right? Well, look at the other line. I want it in the same position over here. Where is that same position? It's right here. Same position. So angle 5 again. All right, which angle is alternate exterior to angle 4? This one some people get much easier. So alternate opposite sides of the transversal, exterior means outside, outside the parallel lines. So here's angle 4. Outside is either 6 or 9. So which one's on alternating sides of the transversal? It's 6. This is angle 6. All right, and then vertical to angle 1. Here's angle 1. Vertical is just opposite it. Opposite of that x. This is angle 4. And lastly, for this type of question, we want linear pair with angle 5. Linear to angle 5. Linear means it adds to 180, right? And next to it, and next to it. So here's angle 5. 2 angles will form a straight line with 5. 5 and 4 make that one straight line. So 4 works. Or I could do 5 here and 1 that makes the other straight line. So angle 1 would be our other option. Okay, number 14, we're going to label the measures of all the angles in the diagram if we know the measure of angle 8 is 45. So this is what I want to see. So if you use that to answer the other questions, let's erase that picture because we're going to label the picture for this problem. So erase it so it looks like this and label measure of angle 8 as 45 degrees. Remember, if you want to write this down, you can. The angles are either the same or supplementary, which means they add to 180. So if they don't look the same, then they add to 180. So find angles that look the same size as this one. Let's find all the same ones to 8. Hopefully you see right here, this one is the same, angle 6. Find some more. Angle 1 is the same, and angle 4 is the same. Those are the ones that are the same or congruent to angle 8. Okay, so those are all 45 degrees. Well, those are all my acute angles. So now all my obtuse angles are going to be supplementary to angle 8. So supplementary means 180 minus 45. And I get 135 degrees. So, all right, there we are. We have the other angles are all going to be 135 degrees. All the obtuse angles are supplementary, which means the two together add to 180. These two together add to 180. So 135 is here, 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 and number 5. That was number 14. We labeled our picture. All right, number 15 says, could the sides of a right triangle be 5, 11, and 12? Justify. Don't just say yes or no. I need to see your work. That's what you use to justify. So a right triangle, I know, has a squared plus b squared equal to c squared. And remember, c always has to be the biggest number. It doesn't matter a and b, but c has to be the biggest number. This happens to be written in order, so C is going to be 12. So let's go ahead and plug these in and see if they're the same. We're asking, are these equal? So A, we'll label it 5. B would be the 11. And C has to be the biggest number, in this case is 12. All right, does 5 squared plus 11 squared equal 12 squared? Let's find out. 5 squared is 25. 11 squared is 121. And 12 squared is 144. Let's see, when I add these together, does it equal 144? Nope, I get 146, which does not equal 144. That line across the equal sign means does not equal. So if they're not equal, then it's not a right triangle. And that's the answer to our question, and we justified by showing work. All right, could the sides of a right triangle be 5, 12, and 13? Which one has to be C and why? Hopefully you picked this one because it's the biggest number. Okay, If they put these out of order, if they told you 12, 5, 13, or whatever, if they put them out of order, you have to know that this one is always going to be C, the biggest one. All right. So 5 squared plus 12 squared. No, it doesn't matter if you put 12 squared first and then 5 squared. That does not matter. But the biggest one is always C. Let's see, does this equal? Question, does it equal 25 plus 144? Will that equal 13 squared, which is 169? Let's see, add those together. I do, in fact, get 169. So is this a right triangle? Yes, because these two are the same. All right, 17, we can do this one. It's not really going to be tested, but just make sure you know these because you'll need to know these when you get to geometry. A pentagon has 5 sides. A decagon has 10 sides. Hexagon, do you know that one? That one's 6 sides. Heptagon, you don't usually hear that one a lot. Heptagon is 7 sides. The main ones you should know, definitely pentagon, definitely hexagon. Decagon you hear sometimes. Dodecagon. So here's your decagon, so you know it's going to be bigger than the 10. Do just means 2 more, so that's 12. Okay. Octagon, you definitely should know that one. That's your stop sign. And a nonagon, we did that on the front side of this page, that's 9. And this one should be obvious. 15gon has 15 sides. Again, that's not tested this year. If I'm using this video in later years past 2019, then just check with me to make sure that's not tested. But for now, it's not. What does it mean if a polygon is regular? Okay, I said that on the front. We talked about a regular polygon has all sides and angles the same. They're all the same. All the sides the same, all the angles are the same. And don't worry about number 19 at this point. We're going to skip that for now, okay? I don't want to confuse anybody. Number 20, though, we can do. Find the measure of each angle of a triangle if the measures are in the ratio of 1 to 2 to 3. Remember, ratio means it can be any number as long as they're multiples of 1, 2, and 3. Multiples of 1, 2, and 3. So I don't know, it's not that it's 1, 2, and 3 exactly. It's not 1, 2, and 3. It's multiples of that. So if I'm going to be multiplying all 3 of these numbers by something, and I don't know what it is, well, when I don't know something, I call it x. So I want to multiply this by x, and this by x. That's how we talk about ratios. Put an x next to it. And you should know that all 3 angles add up to 180 degrees. So let's add them up. There's one, plus another one, 2x, plus the third one, 3x. We can solve for x, and then we'll be able to find the measure of each angle. Well, these are all like terms. 1x and 2x and 3x is a total of 6 x's. And to solve for x, we just need to divide both sides by 6. And x equals 180 divided by 6, which is 30. So now it does say find the measure of each angle. So this angle in the bottom corner where it's just 1x, well, 1x is 30. The top angle, 2x, is 2x's. 2 times 30, which is 60. I'm going to put a box around these because these are my answers. And the third angle down here, this 3x, is going to be 3 times 30, which is 90. So those are my 3 answers there.